Hello, class. Welcome back again for our new lesson vlog. So for today, we will be studying about scientific notation. So let us start. Let me share the screen. So for today, we will be studying about, as what I've said earlier, scientific notation. So by Mama Jane S. Costello, licensed professional teacher, Bachelor of Secondary Education, major in English. Scientific notation is a way of expressing numbers that are too large or too small to be conveniently written in decimal form, since to do so would require writing out an unusually long string of digits. It may be referred to as scientific form or standard index form or standard form in the United Kingdom. So, diba? United Kingdom is part of Europe, wherein France, Britain, Germany, Russia, England, and um, London are included also. So next is this base 10 notation is commonly used by scientists, mathematicians, and engineers, in part because it can simplify certain arithmetic operations. So when we say simplify, it can reduce it into smaller values or smaller digits. Certain arithmetic operations, or when we say arithmetic, mathematical and fundamental operations. On scientific calculators, it is usually known as SCI display mode. In scientific notation, non-zero numbers are written in the form m times 10n or m times 10 raised to the power of n, where n is an integer and the coefficient m is a non-zero real number, usually between 1 and 10 in absolute value and nearly always written as a terminating decimal. The integer n is called the exponent and the real number m is called the significand or mantissa. The term mantissa can be ambiguous. So when you say ambiguous, it has a lot of different meanings, no? So, um, okay, so the term mantissa can be ambiguous where logarithms are involved because it is also the traditional or conventional name of the fractional part of the common logarithm. If the number is negative, then a minus sign precedes m, as in ordinary decimal notation. In normalized notation, the exponent is chosen so that the absolute value modulus of the significand m is at least 1 but less than 10. Decimal floating point is a computer arithmetic system closely. So next is scientific notation examples. So converting scientific notation to decimal notation. So how can we possibly do that? So as what I've said, diba? So 4.52 times 10 to the second power, if the exponent is positive, so we will move on to the right, okay, from left to right decimal places. But if the exponent is negative, we will move to the left, okay? So, for example, 4.52 times 10 to the second power equals 4.52 times 100 equals 452. Next is 4.52 times 10 to the power of 1. So 4.52 times 10 equals 45.2, right? So again, 'di ba nga, if the exponent is positive, you will move from left to right. Yes, left to right. Okay. So if the exponent is 0, so it stays the same. Okay. There's no movement at all. If the exponent is like this, negative 4.52 times 10 to the negative 1. So you will move from what? You will move from the right to left. Okay. Right to left. Like, for example, 4.52 times 10 to the negative 1. So from right to left. So it becomes 0.452. And you will add 0. Okay. Next is 4.52 times 10 to the negative 2 power. So 4.52 times 0.01. So you will move two decimal places from right to left. So 1, 2. Then add 0. 0.0452. Okay, normalized notation. Main article, normalized number. Any given real number can be written in the form of mx plus 10n. Okay, where m is the significand or the modulus. No, not modulus, mantissa. Significand or mantissa. So for example, 350 can be written as 3.5 times 102 or 335 times 101 or 350 times 100. In normalized scientific notation called standard form, in the United Kingdom, the exponent n is chosen so that the absolute value of m remains at least 1 but less than 10. Okay? So 1 is less than or equal m or mantissa and less than 10. Thus, 350 is written. Bigger exponents are due to the normalization, larger than those with smaller exponents, and subtraction of exponents gives an estimate of the number of orders of magnitude separating the numbers. It is also the form that is required when using tables of common logarithms. In normalized notation, the exponent n is negative for a number with absolute value between 0 and 1. Example given, 0.5 is written as 5 times 10 minus 1. The 10 and exponent are often omitted when the exponent is 0. When you say omitted, it is being discarded or removed. Next, scientific notation. A number is expressed in scientific notation when it is written as the product of a number and a power of 10. The number must be greater than or equal to 1 and less than 10. Like for example, 7.5 times 10 to the 7th power. Number greater than or equal to 1 but less than 10. Power of 10 written in exponential form. So how to convert a number to scientific notation? The proper format for scientific notation is a times 10 to the power of p, where a is a number or a decimal, such that the absolute value of a is greater than or equal to 1 and less than 10, or 1 is less than or equal a less than 10. B is the power of 10 required so that the scientific notation is mathematically equivalent to the original number. Next is move the decimal point in your number until there is only one non-zero digit to the left of the decimal point. The resulting decimal number is A pala. Okay, so count how many places you move the decimal point. This number is B. If you move the decimal to the left, B is positive. Okay? So understood. If you move the decimal to the right, B is negative. If you did not move the decimal, B equals 0. Right? Your scientific notation number as A times 10 to the power of B and read it as A times 10 to the power of D. Remove trailing zeros only if they were originally to the left of the decimal point. Okay? Understood ba? Okay, so example, convert 357,096 to scientific notation. Move the decimal 5 places to the left to get 57,096. We move the decimal to the left, so B is positive. B equals 5. So the number 357,096 converted to scientific notation is 3.57,096 times 10 to the power of 5 or to the fifth power. So thank you, class. Another educational vlog has been done, and I hope that you have learned something. Don't forget to subscribe, Hannah Jane Costello. and ring the bell for notifications. Bye-bye from Mom Hannah Jane. Bye. God bless you.